Okay, this is going to review the distance and displacement worksheet packet. So you will be using the graph paper on the next page to draw each of these scenarios. We'll get started with these definitions. Remember the total distance traveled. I showed the map, if you remember, of traveling from one place to another place, like from Bell Gardens to Hollywood. Remember, the total meters traveled would be including any turns, any curves, any change in distance. That's going to be the distance. But then this is going to be the distance traveled from starting to ending point, ignoring the journey in between, like if it was a straight line. Okay, so I'll change color and show you like if this was flying in a helicopter. This straight line from here to here would be your displacement. And then it did the first one for you. It's similar to the one I showed you before, like using the ruler. So if you move 4 meters east and then 2 meters west, you would have traveled a total of 6, but your displacement would only be 2. Because let me show you here, according to this, right? So you're going 4 meters east, and then you're going 2 meters west. You'd end up here. Your displacement would only be 4. The distance you traveled would be a total 4 and 2, which would be 6. I'll show you on the next one. It should be easier to follow. So for the next one, move 2 meters east and 4 meters west. So I'm going to start here for this one. So I'm going to start here. So if you went 2, let me check to make sure. So this one, yes, said 2 meters east. So if I went 1, 2 meters east, that's 1, 2 east. You might want to put yours in a different spot to make sure you have room for all of these. So 2 meters east, and then the next direction is 4 meters west. So then I'll use a different color. So you'd be going back this way, 1, 2, 3, 4. That would be 4 west. So in total, the distance traveled is 2 east and 4 west. That's going to again be a total distance of 6. But then your displacement from your starting point, this is your starting point, you would only be 2 west, 2 meters west. I'll do a few more with you. So 5 meters south and 2 meters north. So you don't even really need to look at the map right now to see the total distance. You know, if you go 5 and 2, the total would be 7. I'll still show you on the graph, and we'll get the displacement. So 5 south, 2 north. So starting here, 5 south, 1, 2, 3, 4, 5. That's 5 south. And then going 2 north, 1, 2, 2 north. So from your starting spot, which is here, you'd end up here. So that would be 1, 2, 3 south, 3 meters south. I'll do one more. So 9 meters north and 12 meters west. So 9 north, 12 west. Let me start here. Starting here, 9 north, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me take that back, go to a different spot. So I'm going to run into the other one. So let me start here. 9 north, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 12 west. So that was 9 north. Let me now go 12 west. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 west. So from the starting point here, you would have, if you're going just a straight right here, this is where you can use that Pythagorean to find the hypotenuse. So if you didn't learn this from math class, you would square this side of the triangle. You can square this side of the triangle and then get the square root. So I'll do this one with you. And you would need to do it this way also for number 8 and number 7. So you would do 9 squared plus 12 squared equals this side squared, which is technically c squared. So 9 squared is 81. 12 squared is 144. And then you add those two together. So if you did 81 plus 144, you'd get 225. And then you can do the square root of 225, which would be 15, because you have c squared here. So to solve for this, you do square root to get rid of this square, because it's squared to the power of 2. To get rid of the square, you do square root. So square root cancels the square, and the square root of 225 is 15. So the displacement would be 15, and that would be, from your original point, it would be northwest. 15 meters northwest. And the total distance is 21. I'll do one more of those with you. So number 7 here, 3 meters east, 4 meters north. So 3 east, 4 north. So 3 east, starting here, 1, 2, 3, 3 east, and then 4 north. 1, 2, 3, 4. So 3 east, 4 north. Total distance is 7. Let's find the displacement. So remember, displacement would be the straight line between these. You would need to use the Pythagorean theorem again. So you would do for this one, 3 squared plus 4 squared equals c squared. So you'd square 3, which is 9, square 4, which is 16, and then you add these two together. 9 and 16 is 25. And then once again, to get rid of that square, you need to do the square root. So square root, the square root and the square cancel each other, and the square root of 25 is 5. So that would be 5 east, north, or northeast. 5 meters northeast. Okay, so you'll finish the rest of those. So this one says a truck travels to and from a stone quarry that is located 2.5 kilometers east. What is the total distance traveled by the truck? So the total distance says it would travel to and from. So to and from, like a round trip, would be 5. And if it ends up back where it started, the displacement would be 0, because it's going to and from. So it would go 2.5 east, and then it would go another 2.5 back. I'll skip ahead to number 3. So a football coach paces back and forth along the sidelines during a close rivalry game. The diagram below, this diagram here, Show several other coaches' positions at various times at each marked position. If the coach makes a U-turn and moves in the opposite direction. In other words, the coach moves from position A to B to C to D. So what's the total distance traveled? So he's starting here, and then he gets to B, A to B. That's 50 to 15. So he started at 50 and went to 15. That's going to be a total of 35 so far. Then he went from B to C, and he was at 15 here, and he's getting to 35. 15 to 35 is a difference in 20. Then from C, he went to D. So here is at 35, and then went all the way over here to negative 5. So 35 here. Let me change color. So if you go 35, and then 5 more, negative 35 plus 5 would be 40. So you add all those up, that would give you the total distance traveled. And 40 plus 35 is 75, and then 75 plus 20 is 95. Now the displacement is just from the starting point of point A to point D. That's the displacement. So where did he start? Where did he end up? So he started here at 50, and he ended up at negative 5. So 50, and then he ended up at negative 5. So he traveled 50, in this direction, and then another negative 5 for a total of 55. And this one, number 5. Two cars start at the same point and drive in a straight line for 5 kilometers. At the end of their drive, their distances are the same, but their displacements are different. Explain how could this happen and illustrate in a diagram. Okay, so this can be shown with the following. So two cars starting at the same point, so this can be the starting point, and the straight line for 5 kilometers. A simple answer for this one is that one car drove in that direction, another car drove in the opposite direction. So even though they went the same amount of distance, their displacement would be different. One might be 5 meters or 5 kilometers east, and the other car could be 5 kilometers west.